Hey guys, and welcome back to a new video. In this video, I got a Jetpack Compose crash course for you. So a whole crash course in a single video. And first of all, if you just clicked on this video, I want to tell you when you should watch this video and maybe if you should also watch my Jetpack Compose playlist. Maybe you already saw Philipp has a playlist about Jetpack Compose. Now Philipp also uploaded a crash course, a single video about Jetpack Compose. Other people have that. So when should you watch this specific crash course? So even though I already have a Compose playlist, which is a bit older at the moment, I still thought it's quite helpful for a lot of people if I put everything into a single video and just condense it a little bit to the most important things, because people nowadays are busy, they don't have a lot of time, and they still want to learn the most up-to-date and most recent technologies. So in this video, I will really cover everything for Compose, starting from absolute beginner, so you don't need to know anything about Compose, and I will teach you the rough basics of it, so you will be able to build some simple UIs, add some behavior, so you can click on buttons that these do things. You will learn how you can style your views in Compose and things like that. So if you're an Android developer and you currently know XML and you want to migrate to Compose, or you're just interested in it and want to see, okay, how is it like, then you can just invest, I don't know how long this video will be, but maybe an hour or so, and then you will have a good understanding of it, or at least a deep enough understanding to estimate if it's worth it to dive deeper into this. We will go through a lot of things in this video, but at the end of this, you will be able to build a simple UI like this, that you have a text field where you can enter a name, like for example, Carl, and then you click add, and it gets added to a list where you can then also scroll. And before we actually dive into coding, I want to quickly talk about what actually is Jetpack Compose. So maybe you're just an Android developer who just works on your stuff, and you start to hear this topic Jetpack Compose everywhere from other Android developers that you have to learn this. So what the heck is actually Jetpack Compose, to just have a little bit of an understanding of it before we dive into this. So initially, when we were to build a UI in Android, then we had to do this with XML. So we had XML files where we just specified our so-called views. So a view like a text view, which displays some text or button or some linear layouts, constraint layouts. And that is what we used initially to build our UI. And then we had these activities here in Android, which we also still have, in which we then inflated these views, or these layouts rather, and also got a reference to these views, maybe with find view ID or view binding, and then just did something with these. However, nowadays we have a more kind of modern approach to this, which is Jetpack Compose. So Jetpack Compose is a new way of building UI for Android. It is a new UI framework, and it has a completely different approach. And in Jetpack Compose, we actually build our whole UI in Kotlin. So we don't have any XML files anymore, at least not for building the UI. As you can see, we have some sample code here. And if you don't know how to create this product, you simply go to Android Studio, file, new project, and then you need to select empty compose activity, and then Android Studio will generate this exact activity I showed you here. And there's already a lot of stuff going on here if you take a look at this. So we do have the set content function, which is the Jetpack Compose equivalent to set content view, which you know from XML, which just assigns a certain XML file to our main activity. Here we use set content, and we have these lambda blocks in which we now define our so-called composables. So what was initially a view in XML is now considered a composable. And let's ignore what is inside of this block here for now and scroll down a little bit to our function greeting. That is exactly such a composable I talked about. So we do have this composable annotation. That is what makes sure that we can kind of apply the special Jetpack Compose code in this function, because a composable in the end is nothing else than a Kotlin function. So we can create our very own greeting function, which is just generated by default here. We can give it a name, and then we can have the so-called text composable, which just comes from the Compose UI framework. So that is already contained, which is the equivalent to a text view. So we just call this Kotlin function in our code now to add this text on our screen. And we just specify a normal Kotlin parameter here with the text we want to show on the screen. So we just say hello, and then whatever we passed for this name. Then we do also have this default preview function here, which, the preview is basically what was the layout inspector initially for XML, so where we can actually see what we are building. And here in the default preview, we do have this Jetpack Compose crash course theme. Let's ignore that for now. That just gives our UI some theming attribute. I won't get into this in this crash course since it's not really essential here to build basic UI. And then we do have this greeting function, which we call here. And if we take a look into that, so we do pass Android for the name, then this greeting function gets called with Android, and that will call the text composable, which will simply draw a text on the screen that says hello Android. And if we go to our split tab here on the top right, then this is our preview. So if we now want to see what is on our screen, we actually need to go to the split tab and click build and refresh. And then whatever we have here in this preview annotated function will be shown in our preview tab here. So now Android Studio is actually building this, and then you can see initializing, and then we see hello Android. That is now the text that gets added on the screen, that gets drawn on the screen. And if we now change this Android text to, for example, Philipp, then we also do see that this gets updated here in real time. Hello Philipp, capital H, let's remove that, like this. And then, we successfully actually changed our text on the screen. So this new way of building UI, which is actually called the declarative approach, so it's declarative UI design, is kind of a new way of thinking. Because initially with XML, we have these views and we were more like commanding them to do something. So please view.text is equal to something. So we do actively tell it to change the text. Now in Compose, that's different. Here in Compose, we have this concept of state. In this case, this name would be state. And as soon as that state changes, our text will also kind of change, because here we don't really have a function that we can call on this text. So we don't save this text in a variable like this. That wouldn't make any sense in Compose, because it's a new way of thinking and a new way of building UI. I will get much more into detail in states later at this video. Right now, I think this would overwhelm you. But let's first of all, just see what else we can do with this text composable here. We can completely ignore this code up here. This would be just our production app, whatever gets shown in the app. But for us, it's totally fine here if we just work on our little greeting composable with our text, which we then see in our preview. So of course, if we display a text, there are very often scenarios where we want to kind of style it. We want the text to be, to look different. And we can do this by adding just more parameters to this text function, to this text composable. So only this text is mandatory, of course, because every text needs a text to be displayed. But if we hit Control P here, so we see all these parameters we could now apply to this function. For example, color. We could add a color to our text, which is simply color.blue, for example. Let's import that. And then if we take a look on the right, and then after this loaded, we will see that we now have blue text. So we now rather just describe how our UI looks like in Kotlin, rather than having these XML files, which we then inflate in Kotlin. But let's see what else we do have here that we could modify. You can see we have a so-called modifier. I will get into that next. That's a little bit of a bigger topic. But let's skip that for now and take a look at the font size. So we could simply specify a font size for that to make it bigger. Let's say 30 SP. How do we do SP here? In XML we did this, but in Kotlin we need to say 30.sp. And then we can hit Alt Enter to import that. And if we take a look on the right, now we have a much bigger text. And the same way we can change and manipulate all the other relevant text attributes. For example, the font style, so which font you have, the font weight if you want to have a bold text, font family, letter spacing. So you have a lot of options which you can now very easily style in your Kotlin code. But as I already teased it a little bit, let's get into these so-called modifiers next. So what is a modifier? That is a completely new concept in Jetpack Compose, which we don't know from XML. And these modifiers are, well, as the name says, used to modify our view, or in Compose terms, our composable. So there are always certain things and certain transformations, maybe alignments, that we want to be able to be applicable to any kind of UI component, to any kind of view. So we take a look at all these text-specific attributes here. These are, of course, only relevant if we do have text. But for some attributes, like, for example, where we want this text to be positioned on our screen, or what kind of background color the box around this text has, that is something that is actually relevant for any type of UI component. And for these things, we use these modifiers. So we can assign a modifier by first of all specifying the modifier, and then we can say dot, and we have a ton of different options here that we can use to modify and change the appearance of this composable. For example, we can say we do have a background color, and the background color would be color.red, for example. If we then take a look at the right, after this loaded, then we see we do have a red background now. And these modifiers are really applicable to any type of UI component. You will be able to assign these to all your composables. So what else is a common modifier we use? For example, padding. We know that from XML, it just adds spacing to the outer corners and outer edges of our composable in this case. Here we do have different overloads where we can, which we can use to add padding. We just use this all option here to, for example, add 16 dp of padding, so 16.dp. Alt enter to import that. And if you take a look on the right, we now have this padding here around our text. And what else could we have here if we just write a dot? Then we do see we also have fill max width. I will get into that later. So we can just assign a certain size to our composable. We do have functions like clickable to make it clickable. So we can assign an on-click listener to this composable. We can give it a border, we can clip it. So we have round corners, or we have a circle shape or whatever shape we want. We can give it some alpha value, so make it transparent, and a lot more. And these view transformations are now really a lot easier in Compose compared to XML. For example, if you wanted to give a view rounded corners in XML, which is not a card view or so, then you needed to make like an XML file in your drawable folder, then add that as a background resource, and that was a lot of pain. These things are now a lot easier with Compose because you don't have these limitations that you need a certain view, like a card view, to add border radius. And what is also very cool about these modifiers is that they are working sequentially. So what does that mean? If we take a look at this, then the first function we call here on this modifier will be executed first. Then this will be executed. So in this case, we first of all paint our background red, then we add some padding, and whatever we now apply only applies to the area where we applied the padding before. So if we now add some background again, so we can kind of chain these, and let's say color that green, and take a look on the left, on the right, then what we'll see is we now have this green box around our text and the red box around this, this big rectangle. So we first of all have our red background, then we add 16 dp of padding. So we're here. And now if we actually apply our green background, it applies to this inner rectangle, which we applied the padding to before. If we were to swap these, actually, let's do it like this, then you can already guess what happens. Then our whole background is green because we first of all apply the red background to everything, then the green background to everything, and then we apply the padding. So after the padding, we don't apply any background anymore, which is why the green background is simply overlapping the red one in this case. So that is the very basics about modifiers. We will learn more about these in this video, but let's show you something else. Let's remove this modifier and we just take this text. And let's say we want to show two texts on top of each other. So we add this down here and we say, that's something else like hello or some other text like this. And if we now take a look here in our preview, you see that is not really what we want because we see that our other text is drawn on top of our hello Philipp text in this case. So that is a very, very important concept or very important to understand and Compose, that if you have two composables that you call directly one after another here, then whatever is called the latest will be on top of our screen. So this is drawn first, then this is drawn, and if you would have more, then these would also be drawn on top of these. And of course, that is not usually what we want. Here in this case, we actually want to, first of all, have our text, hello Philipp, and then have our other text, which says some other text. How can we do that? Well, we can achieve that with so-called layouts. You already know these layouts from XML. We have linear layout to just lay out certain views. We do have constrained layout. We do have relative layout, and all these common layouts we used in Android. In Compose, we also have these. They're just called a little bit differently. For example, to arrange our composables here on top of each other, we use the column composable. So we write column. We don't need to add something here in the parentheses, and then we can take our two texts and move them inside of this column. So this block will now contain the layout code, and now if we take a look, we see that they are now actually laid out exactly as we want. And here for this column, we again have the option to pass a modifier, for example. For example, we could give this whole column a red background. And then if we take a look on the right, we will see, that's exactly what will happen. So to every single composable, you are able to apply these modifiers. You can also make the whole column clickable, for example, by saying modifier.clickable. But we get into this later. And then let me quickly zoom out a little bit here. What we can also do with the column is, we can say that we, for example, have some kind of horizontal alignment. So we say how these views are arranged or aligned in this column. So we could say Okay, we say end, alignment.end. And if we take a look here, then this will push all the composables in this column to its end in a horizontal direction. And we also do have the same for vertical arrangement. So here's called arrangement, which we can use to just spread out these views in vertical direction. Let's try this vertical arrangement, for example, center. And if we take a look on the right, we will see that actually nothing changes. Why is that? Well, because our column currently uses the minimum amount of space it gets, which is basically equivalent to wrap content in XML. So that is the default for composables. But yeah, that is why it simply does not have any space to arrange something in center vertically. How can we give it some more space? Well, we can use the modifiers for that again. That is what I teased before. So we can add a modifier here. And what we can do is we can say fill max size. So that is a modifier which will simply tell our composable, our column in our case, that it should take all the space it can get. So in our case, because we place it at the root of our UI tree it will simply fill the whole, our whole screen, the whole width and height of our screen. If we do that, take a look in our preview, then we need to zoom out a little bit more. And now you can see this is now a whole screen. And you can also see that our content in our column is now centered vertically. If we were to change horizontal alignment, for example, to center, then you will also see it's actually, how's it called? Center horizontally. Then you will see that this will also center our text horizontally now. Sometimes we also only want our column to fill the whole width, but not the height of our screen. Then we can say fill max width or fill max height. So for example, fill max width would simply, just fill the whole width, but not the whole height of our screen. Or if we want to give it a fixed size, we can also do that with the size modifier. So we can say size, and let's say 400 dp. Then this will be a square that is 400 by 400 dp, as you can see here. So our column is now the white square here, and in it we can see our centered text. What is now important here regarding these size modifiers is that if something in our parent composable has another modifier with fill max size, then this will not fill our whole screen. This will actually fill the whole size of our parent because our parent has a fixed size. So this does not automatically fill our whole screen, only actually if our parent composable does not have a fixed size. And you can see, because it is fill max size, it also pushed our other text out of the screen. So that is usually not what we want. And you probably already guessed it. If we have a column, we also have a row to arrange items horizontally. So here these attributes are not applicable anymore because they are swapped. We do now have a vertical alignment. So vertical, or how is it called? It's horizontal arrangement. Horizontal arrangement like this, for example, and if we now take a look here, then our texts are now arranged next to each other. So that is basically a linear layout with horizontal orientation. And the rest actually works exactly the same for this row as it also did for the column. And one more layout I want to show you, which you very commonly need, is the so-called box layout. The box layout is the equivalent to a frame layout in XML. So we can say we do have a box, and with a box we can place views on top of each other. So basically what is the default, but it still allows us to kind of arrange these inside of the box. So if we get rid of this and just leave the modifier, then you can see that is exactly what we had before, that our texts are shown on top of each other and the bottom text is on top of the top one. But what it now allows us is to also arrange these composables here inside of this box by adding some content alignment. And here we can now align our views, our composables, alignment dot, and the bottom center, the center, for example. So basically top left, top center, top right, center end, or so it's called. And you can see now all the views move to the center of our box. They're still on top of each other because this content alignment parameter applies to all composables here. If we don't want that, we can also apply modifiers again, just to a certain text here. So we can say this text should now be put in the bottom end corner. So we can say modifier.align, and that modifier is only available here in this box scope, which we have here, because otherwise it wouldn't make any sense. And then we say we have bottom end. If we now do this, then our text will be put in the bottom end corner here, and now they're not overlapping anymore. So this is very useful in a lot of cases I use box, yeah, all the time, and it's definitely important to know about that. So that is it for the basic layouts in Jetpack Compose. We also do have a constraint layout, by the way, which I never use because these rows, columns are actually more efficient in Compose. So in XML, it's the other way around because there, if you nest layouts, that harms the performance of your UI, but in Compose, it actually does not matter. So let's get rid of our box and let's get into images. Just quickly seeing how we can add an image to our UI. We can simply do this with the image composable. Here we need a so-called painter, which kind of just paints our image on the screen, kind of. We do have different overloads here. If we want to paint a certain resource on our screen, then we can do that with paint a resource. So that's basically the equivalent to having an image view in XML and then calling, I think it's a set background resource or so on that with a given ID. So we can say paint a resource, r.drawable dot. Yeah, I don't have any images I added here. Let's just choose the foreground of our launcher icon. And we also do want to add a content description. We do have to add one or set it to null. I'll just set it to null here. That's just for accessibility here. And if we now take a look here, then we see this little Android symbol. We can give it a background to make it, a little bit more prominent. Saying modifier is modifier background. And let's say color that black, for example. Then we should be able to see our white Android hat. And what is also very useful is instead of images, we can use icons. An icon is basically the same as an image, just that it is vector only. So yeah, if you really just want to show a shape on the screen, but not any photographs. So you can have an icon. We want to choose this overload with the image vector. And here Compose comes with a lot of predefined icons from the material design library. Here we can simply say icons.default, and then, for example, have our add icon, which is simply the plus to add something. If we then add a content description, which we set to null, we should be able to see our add icon on the screen. Not sure if it's white, it's actually black, but we don't have a background. So if we zoom in, we see we successfully now drew an icon. Okay, now that we know how to draw images and icons on our screen, something else that is very important is what if we actually want to have some kind of conditional UI, for example. So if we sometimes want to show this icon and sometimes not, based on some kind of condition. Let's say if the name has a length that is longer than 5 or so, we want to show this icon and else not. In XML, we could simply use an if statement and then, just change the visibility to false or so of that view. How do we do this here? Because none of these composables actually has like an attribute visible or so that we can set to false if we want to hide it. No, in Jetpack Compose, we can actually also just use normal Kotlin language features like if statements. So we can, for example, say if the name.length is larger than 5, we want to show this icon, we move this in here. And then if that is actually the case, here it is the case, it is shown. And if it's not the case, let's remove some letters, then it should not be shown. Yes, now it's actually hidden. So these if statements work the same way as before. And something that's also very cool is let's say we move this out of this if statement again. If we want to show a lot of these icons, then let's add a column. Let's just leave it like that. And let's say you want to show 10 icons. So instead of just mentioning 10 icons here as a composable, we can also just use a for loop, just normally as we do it if we want to repeat something. So for I in 1 to 10, let's say, then move that in here. And since we put that in a column, these will now be placed on top of each other, as you can see here. So that is very cool and works, very intuitive in my opinion. And now when we already have something like this here in our preview, which is kind of a list, let's get to the next topic, which are lists. So in XML, I'm sure you remember recycler views. Recycler views are kind of the standard way in XML that we can use to make lazy loading lists. A lazy loading list is basically just a list where only the items the user is currently seeing are actually rendered on the screen are calculated in terms of logic, but all the items that are not on the screen are simply hidden, so they don't end up using any resources. And if you've ever implemented your own Recycler view in XML, you know how much of a pain that can be. Because you first of all need to specify it in your XML file, then you need to kind of assign a layout manager how the items are actually laid out on the screen. And most importantly, you need an adapter. So you need to override a bunch of functions, define how your binding logic actually works. And that was a huge pain, and it actually took a while to make such a Recycler view work. In Jetpack Compose, that is now a lot easier. So one way to define a list is simply using a column like we did here, and then inserting a bunch of composables using a for loop. However, that does not yet have this recycle behavior, since this will simply compose and draw all of our icons on the screen at any time. Even if these icons are not on the screen and are somewhere out of the screen, they will actually be in memory and need resources. What do we now do if we want this recycle and lazy loading behavior in Compose? Well, we simply need to replace this column with a lazy column, and that's pretty much it. All we now need to do is we need to replace this for loop with a specific block that we can only use for lazy columns, which is items, and we want to use let's use this items with a count, and then we say we have 10 items, and here we then get our index I. And if we now check back, it's exactly the same result, but now we have the lazy loading behavior. So if we actually add a modifier here, let's say modifier fill max size, so it simply fills the whole size of our screen, and we then make use of that here in our actual app, so we can actually open that. Let's simply remove this surface. We don't need this, and just have this greeting here. We also don't need a name anymore, but that doesn't matter. Let's just leave it like that. Launch our app on our emulator and take a look here. That's now launched, and here we can see our list. These icons are of course very small right now. Let's increase the size of them so we actually see that it's a real list and we can scroll. So here for these icons we can assign a modifier, let's say with a size of 100 dp, very large icons. Relaunch this, take a look here, and then here we have very large icons, and we can now scroll in this list. So it's the same behavior as we have with the Recycler view. These icons that are not on the screen are not actually rendered and are not calculated, but the other ones are, of course. And the same way we have a lazy column, we of course also have a lazy row, which you can simply replace this with. So if we use a lazy row, relaunch this, take a look here, then you can already guess it, we have a row in which we can scroll. So this is very cool, very easy how we can now do this in Compose, and it's not as much of a pain anymore as it was with XML. So that's it for lazy rows and lazy columns to build some lists in Compose. The last topic I really want to face here is state, and that is a very, very important topic, so listen carefully. After that, we will actually build our little UI that I showed you in the beginning, where we can enter some text, add that to a list, and then just dynamically add these items and scroll on our list. However, as you probably already guessed, what we did not cover yet is how can we achieve actual behavior with our UI, so that if something happens, so if we click on a button, for example, that a certain part of our UI changes. And to understand that more, we need to dive a bit deeper into composable functions and in how these work, and into the concept of state. So first of all, what is state? A state is in the end just a value that can change over time. So this could be a text in a text field that could change. So in this case, this would not be state, since it's simply a value that does not change. This will never change since we simply hard-code it here. But if this is text that we could potentially change, where maybe letters get added or so, then that would be considered state. So imagine we want to build exactly that. We do have a text and a little button, and when we click on that button, we want to simply add some kind of letter to our text. How can we achieve this? Let's simply go to our set content block right in here where we have our greeting. We don't need the greeting anymore, so let's forget about that. And let's also remove this here so it does not confuse you. We can remove it here in the preview and simply also close the preview. From now on, we will just work with our actual app in our emulator. So in here, we will first of all have a little column. Nothing new for now. We want to add a modifier to simply fill the whole screen size. And then in here, we add a little text, which might simply, just display number. Let's not just say we add something to the text, but let's rather increment this number and see how we can do that after pressing a button. So here we have a text, we then have a button. We can simply use this button composable for that. Here we get an on-click function. When we click on this button, obviously, then this block of code will be executed. And here in this block of code, we put in the content of the button. So in our case, the content is simply text. But in Compose, you're so free that you could also choose images. You can put anything you want in this button. So we could have a text here that says, click me, like this. And when we click this button, then we want to increase this number of our text. So if we take a look here, if we simply launch this now emulator and see how this looks like, then you see we simply have a number here and the click me text. We can also style this a little bit so it's a little bit larger by going in here in our text composable and saying we have a font size of 30 SP. Let's minimize this again. And we then say in our column, we have a vertical arrangement of center and a horizontal alignment of center horizontally. And then we should be able to see a little bit larger text in our center of our screen. Yes, and when we now click this button, right now nothing happens, but we want to increment this number. How does that work? Well, for that we need state, because this number would be considered state. It's a value that can change over time. It's a value that changes when we click the button. So how do we declare the state? We want to go up here and we want to declare the state by simply having a var, since it's a value that can change. And this could be considered count. And we say by mutable state of. That is the way we define state in Compose. And we need to import this. So Alt Enter import. And let's actually also get rid of this by keyword for now. I will explain what that is. And right now we get an error here, and that is intentional. We shouldn't do it like this, but let me explain first what happens here. So we first of all declare a count, which we set to this mutable state of, and the initial value is 0. So that is the starting value of our count. But why, if we hover over this, does it say creating a state object during composition without using remember? So to now understand why we can simply call this function in here, or why we shouldn't call it in here, we need to further understand how Compose works internally. So Compose is actually a lot smarter than you think. If you have such a state, such a value that can change over time, and you end up using this to, just assign that to some kind of parameter in your composable, let's say count.toString, and if that value then changes, Compose is smart enough to actually take a look in your UI tree. So it will go through all these composables and see where this count is actually used. And only for those composables where it is used, it will actually redraw these on the screen. And that is what we consider as so-called recomposition. So whenever a state changes that a certain composable uses, then that certain composable will recompose. And if another composable, which does not use that state, also does not recompose, we consider that being skipped. So in this case, this text would recompose if our count is increased. However, this button would not recompose since it does not use any of this count state. And this also only works if we define our state with this mutable state of. So this mutable state of contains this information that all the composables should actually listen for these mutable states, or rather to these states in general, and just listen to changes and be recomposed when a certain value changes. And since whenever this value now changes, this whole function here will be recalled. Since all of these things are just functions in Kotlin, all the lines that are in between, like this here, will also be recalled. And imagine whenever any type of state here changes, this line would be recalled. That would mean that we simply assign the default, the initial value of 0 to our count again. So it's not really saved. So this would lead to a lot of bugs here. If we want to save this, we actually need to wrap this around a so-called remember block. So we can say remember, and in here we have this mutable state of. So remember will basically just make sure that this code is executed once, and then the value of it is simply remembered. So it won't actually assign the initial value again on every single recomposition. We can do it like this, and then we can refer to the value of our count by saying count.value. Or if we don't want to write value all the time, we can use this by keyword and then we can simply use count.toString. So if we now simply go to our button on click listener and we say count plus plus, here we simply want to increase count, and we launch this app, take a look here, click this button, then you will see that our number is actually increasing and our text will update correspondingly. So I know this concept might be very confusing if you are new to this. Let's go through this again. What happens here? So we first of all simply declare this count. We declare this as a mutable state of, so just a value that changes over time. It's mutable, so we can change it on our own, and the initial value is 0. Then we declare our button here with an on-click listener. When we click on this button, this block will be executed, and we increase our count by 1. As soon as this happens, as soon as the number is increased, Compose will now look in our UI tree and see where this count is actually used. And in our case, it's only used in this text composable, so it will actually recompose this text composable with the new value of count. So it will simply update the text with 1, with 2, 3, and so on. And the same way we could also use the count in here, for example, click me count, and then our button text would change correspondingly. If we take a look in here, then now both these values would change. In this case, this text composable would recompose and this text composable would recompose, since both these refer to our count text. And now we actually have all the knowledge we need to be able to build our simple UI with a text field where we can enter a value and then add a certain name to a list. So let's get rid of all this here and start to implement that. So first of all, I want to have a row in the top where we have a text field and a button next to that. And then below that row, we will have our lazy column in this case, which is simply a list of names where we want to add a new name when we click the button. And since we first of all want to arrange these items vertically, so we first of all have a row and below that we have our lazy column, we need a column as the most outer composable, the most outer layout. We want to say we have a modifier of modifier fill max size. And we could also add a little bit of padding here of 16 dp, for example. And then in here, for this column, we actually want to have a row, first of all, which contains the text field and the button. So these will be arranged horizontally, which is why we use a row. For this row, we simply want to fill the whole width of our screen. So fill max width. Otherwise, it would occupy all the space we actually need for our lazy column. And in here, we now want to have our text field and our button. A text field can be created simply with a text field composable, that is a normal material design text field. We also do have an outline text field like this, and we do have a basic text field, which is which allows us a lot more styling, but does not have any fancy functionality like hints or so, which the material design text fields do have. Let's actually use an outline text field here, which I think will look fine. Press enter. And now we need to specify a value on the one hand and an on-value change function. So text fields also work quite differently compared to XML. So what do we now need to assign for the value? The value is simply the text that is currently entered in the text field, and on-value change is a lambda that will be called with the new text after it was changed. And here we actually need to make this text field text a state, since that is a value that can change over time. Since if we enter it, the text of the text field will change. So what do? We scroll up, and in here we declare our state, which is called, let's just call it name or so. Since we want to enter a name, we say bar remember again, make sure that everything is imported here, and we say mutable state of, and the initial value is simply an empty string. So we start our text field state with an empty string, it's just an empty text field, and we enter our name here as the value. And then what happens if the value changes? So when the user types something, then we actually need to assign the new value to our name state again, so our text field will show that. And that's actually what we call a two-way binding, since the same state that causes the state change will also trigger this on-value change function again, which will then update this, the state again. So this is just how we have to do it here in Compose. We should simply say the name is equal to our text, so the text that was changed, and that change will then actually recompose this outline text field to display the new name. And then next to this outline text field, we actually want to have a button with an on-click listener again. Here we want to add our person, our name, to our list. Let's leave that empty for now and just add a text to this button. The text is simply add. So now we have our very first row, or the very first part of our column. The second part of our column is then our list that simply reflects all of our names. And you already guessed it, this list of names is also a value that can change over time. So that must be state. So we can say var names, so all of our names that we added so far. By remember, we say mutable state of, and that is simply an empty list initially of type string. And if we now scroll down below our row and we specify a lazy column here, since that is what we use to show a bunch of items, now we can say we have our items block, just as we did before. This time we want to choose the second overload, since it takes a list of items and we have a list of strings here, so that will work perfectly fine. And then we can say we actually have our names list. Open this block of code, and here for every single, let's call it current name, we get the reference here, and we can use that to show a certain item. For example, a text. So you can say a text with the current name, and that will already be enough to show a list of names. Let's now go to our button, since currently we don't do anything when we click on add. In here, we want to say we take our names list and we simply add our new name to it. So names plus name. So whatever the name state currently is. Let's only do this if our name that we entered in our text field is actually not blank. Then we do want to add this here, so like this. If we now launch this, you will note that this looks quite ugly at the moment, but it will be a functional UI. So in here we have our text field. We can enter a value, for example, Philipp. And if we then click add, we will add this value to our list here. Right now our state does not reset, so the text remains in the text field after we actually clicked add. So we can add Philipp a lot of times here, and it gets added to our list. So if we do this, until it reaches the end of our screen, we will also see that we can scroll here. Right now, this is of course quite ugly, so let's make this a little bit more beautiful by adding some spacing in between here and also filling the whole width of our screen, and also to give these individual text a little bit more space, maybe add a little divider or so. So let's go to our row here first of all and add a little bit of spacing between our outline text field and button. We can do this with a so-called spacer, which just takes a modifier, and the modifier can simply be width. So we just assign a fixed width amount of, let's say, 16 dp, and this will just be an invisible composable, which just occupies a little bit of space. So if we now launch this, you will see that there will be a little bit of spacing between our text field and our button. You also see that our button is not really at the end of our row, so this space is more than this space. That is because we have a default kind of width for text fields in Compose. If we want to change this, we can go to our row, or actually to the outline text field, and add a modifier of modifier.weight1f. Weight is the modifier that is only applicable in rows and columns, which is basically the same as a weight in a linear layout. So if we assign a weight of 1 here, that means that this outline text field will simply fill all the space it can get, or rather, if we say it differently, then these other composables here inside of our row in this case will take just as much space as they need, and this outline text field will take all the remaining space. If we were to also add a weight of 1 to our button, then the outline text field and button would share exactly the same amount of space in our row. So if we now relaunch this, take a look here, you will see that now it looks much better. But we still have the issue that if we add a name here, then it looks very cramped. So let's fix that as well. We first of all want to go in here in our on-click listener for a button, and we want to reset the name to an empty string after we clicked it. So we just say that our text field is empty again after we clicked our button. And then here in our lazy column, we can actually go ahead and assign a modifier to this text, to each one, and say we have a modifier, first of all, to fill our whole width. And then we can add a little bit of padding to these, so they just have some spacing. So padding 16 dp. And if you want, you can also add a little divider here, like this. So we see that below every single text. If we now relaunch this, take a look here, then add a name here, click add, it disappears here, And here we have our list item in our list. We can add a different name here and so on. So now that is looking a little bit better, not too fancy, but I hope you understand how this now works, because every single time we type something here, our name state again changes. So this one here, then Compose will actually take a look at all these composables where this name state is used. It will find it inside of this composable here. It will recompose this, and yeah, then it will reflect the new name state. And the same way, if our names state, so plural, is actually changed, which happens when we click on our button, Compose will see, okay, the name's actually changed. Let's see where this state is actually used. It will check here, okay, no. Here in this lazy column it's actually used. So this lazy column will recompose and it will actually add the new name to our list. And in my experience, like I've now been working with Compose for 1.5 years roughly. And in my experience, this new approach, this declarative UI design approach, is a lot less error prone, since you really manage your whole UI state on your own. Like in XML, for example, if you have a text field, this kind of state management logic is already handled inside of the view. But here in Compose, you really need to handle it all. But that really allows you the maximum amount of freedom. And since you can now also just take these single parts of your UI and put them in composables, like we can simply take this list here and say down here, comp, which is the abbreviation for composable, simply say we have like a name list or so, put this in here, we pass in a name state, which is a list of string here, and we should also always provide a modifier if we if we create such a composable function like this. We can set this to the default modifier, just that we can change the appearance of this from the outside. We can assign this here. Now that we did this, we have a reusable UI component, and that is the true power of Compose, since now we can simply insert such a name list by simply having one single function call. Like here, we can say our names is our names, and wherever you now want to use this exact list in your project, you can just do this with this single call. And this is not so easy with XML. So you do have these include tags and stuff like that, but it really is a pain. And for a lot of things, you need to implement custom views in XML, where you need like a separate class, inheritance, and all that stuff, which is a lot of effort to implement. In my experience, it's a lot easier to just quickly create such a composable, to maybe have just a custom styled button for your app. Maybe you have some custom branding guidelines, and you need these buttons across your whole app. Then you now only need to implement a single composable for these, and you can very easily use these then across your app. So I hope this gave you a good introduction. Of course, there is much more to learn about Compose. If you're just looking for some more advanced topics, then take a look at effect handlers, which are quite important to know to not mess things up, but these are rather advanced. You can take a look at animations in Compose, which I also have a video about, just as about effect handlers. And I would just recommend you to build some simple UI, maybe take a very simple design from Dribble or so, and try to implement that in Compose. And it's really not an issue if that takes some time, because you will definitely learn a lot on that journey. And if you want me to help you on that path, then I have a lot of premium courses on Android. So if you're looking to become industry ready as an Android developer, learn more about Compose, learn more about architecture, then I have a lot of helpful courses about that for you. So you can check the first link in this video's description to just learn more about these courses and where you can get these, what they will teach you. Check these out. And apart from that, thanks a lot for watching this far. I hope this video taught you a lot, and I will see you back in the next video. Have an amazing day. Bye bye.